The question says among the following complexes K2P, you can see following complexes given here, and it says the diamagnetic complexes are. We have to identify which complexes are diamagnetic by nature, means they do not have any unpaired electrons. Okay, they do not have any unpaired electrons. Okay, always keep in mind, in general, the complex which have a strong field ligand, and we have learned a strong field ligand cause pairing of electron, and when they cause pairing of electron, so what will happen? Diamagnetic character increases. And in case if we have weak field ligand, in this case what will happen? No pairing of electron is there, and in this case what will happen? Paramagnetic character increases. Okay, so now we have to identify in which complex strong field ligand is there, because strong field ligand will be causing pairing of electron and will be leading to higher diamagnetic character. And one more thing you should keep in mind, if the central metal atom is having odd number of electron, definitely it will have paramagnetic character. Why? Because you can see, even if the strong field ligand is present or weak field ligand, doesn't matter at all. If the central metal atom is having odd number of electron, then it will have paramagnetic character, because complete pairing is not possible. Now let's say if I mention D3 is there, central metal atom is having D3, outermost electronic configuration. Okay, in this case, even if the central metal atom is attached to a strong field ligand, if you cause the pairing, so in this case what will happen? Pairing, and one is still unpaired electron is left, so it will be leading to paramagnetic character. Okay, complete diamagnetic property will not be there. Okay, now first of all, we identify in which complexes we have a strong field ligand. You can see we have cyanide ion. Of course, it is a strong field ligand. In this case, pairing of electron. I will highlight. In this case, ammonia is there. It is also a strong field ligand. Pairing of electron will be taking place. Next, we have oxalate. You can see it is what? Didentate, and it is also considered as a chelating ligand. Chelating ligand cause stability, lead to stability of the complexes. And strong field ligand also lead to stability of the complexes. They cause more splitting. Hence, we can consider it will also cause pairing of electron. So, in this case also we have diamagnetic character. This is what water molecule is there. It is a weak field ligand, and weak field ligand increases paramagnetic character. Then we can skip this complex. Okay, next we have cyanide ion is there. It is also a strong field ligand. It will be increasing the diamagnetic character. And next we have H2 is there. H2. But in case of zinc is there, what happens exactly? You can see if you calculate the oxidation number in this case. So you can see this is neutral molecule. NO3 minus is there. It also plus 2 oxidation number in case of zinc. So what will happen? You can see if you write the outermost electronic configuration for the zinc, it is having 30. This is what 3d10, and it is what 4s2 is there. Zn, it is having plus 2 charge. Then in this case, outermost 2 are 3d10. D orbital is completely filled. So in this case, doesn't matter strong field ligand is there, a weak field ligand, D orbital is completely tight packed with the spins, with the electrons. So this is also showing diamagnetic character. Okay, because if you fill the electrons, so what will happen? Completely fill. 1 2 3 4 5 6 7 8 9 10 is there. Singly fill or double fill, whatever you do, it will be completely tight packed. Okay, it also shows we have a diamagnetic character. Now you can see we got only one complex. As a paramagnetic, but in the options you can see only four complexes are given here. Okay, so now the second part, we have to identify in which complex the central metal atom is having a strong field ligand. It is already decided, but now next we have to identify in which complex the central metal atom is having odd number of electron. Means complete pairing of electron will not be taking place. So first complex, you can see if you calculate the oxidation number, in this case I'm talking about this one. Okay, so we have 3 potassium is there. Calculate oxidation number. Okay, potassium 1 is there. We have 1 plus, we have Fe is there, and plus 6 cyano group minus 1 is equal to 0. So we have plus 3, and this is what Fe, and minus 6 is equal to 0. Fe is present in plus 3 oxidation number. Now we can write the electronic configuration in this case. So Fe 3 plus is there. For Fe we have atomic number is what, 26, outermost electronic configuration 3d6, and it is 4s2 is there. It is having plus 3 oxidation number, it will be losing 3 electron, then it will be 3d5. You can see we got odd number of electron. Okay, in this case you can see cyanide ion is there, strong field ligand is there. Okay, but in this case d orbital is what, having odd number of electron. Then we can eliminate this one. We eliminate it. Does not show diamagnetic character, it shows paramagnetic character. Even if you carry out the pairing of electron, complete pairing of electron will not be possible, because you can see here we have 2 electron, then 2 electron, 2 electron, 2 electron, and then a single spin is there, like this. So still it will have paramagnetic characters. So we got let me circle, we have L is there, okay, and then M is there, we don't have N, O is there, and P is there. Okay, L M O P, L M O P, you can see option B is correct. Option B is correct. Very interesting question. If you like this video, please share and subscribe to the channel.